Okay, let's turn our attention to the mean value theorem. If f of x is continuous on the closed interval a to b and differentiable very key, there are now two conditions instead of one, on the open interval a to b. Now notice that it's not doesn't have to be differentiable at the endpoints, simply because if those endpoints are actual endpoints, then there is no derivative, there's no single tangent line at that point. But it's okay, it's just got to be in between the two endpoints that is differentiable. It's got to be continuous for the entire interval, including the endpoints. Then there exists a number c, this is for x, in the interval ab such that f prime of c, the derivative, equals f of b minus f of a over b minus a. For the differentiable piece here, really what we're worried about, since we already know that it's continuous, this means no sharp turns. So let's restate that geometrically. This means that if a function is continuous with no sharp turns, if you draw a secant line through 2 points, somewhere between them is a point whose tangent line has the same slope as the secant line. Here's what this looks like. Let's say we've got our little function. Here's a, here's b, f of a, f of b. And there's a nice smooth curve like that. This point we know is the point a comma f of a. And this point we know is the point b comma f of b. And if we draw a secant line right through those, we can find the slope of the secant line by doing f of b minus f of a, that's change in y, over b minus a, that's change in x. So that's this little part right here. Now let's imagine that we just took that and we just moved it up here. At some point, we're going to reach a point right here, let's say, where the slope of the tangent line right there is parallel to the slope of the secant line. So let's say this is the point C, f of C. We know that the slope of the tangent line at x equals c is f prime of c. That's what this is saying. That the slope of the tangent line at this point, somewhere on this interval, there's going to be a point where the slope of the tangent line here is the same as the slope of the secant line for the interval overall. One thing to be wary of, this does not work if there's a sharp turn. Let's say we've got this situation. Here's our little secant line. But we notice that this point doesn't have a tangent line because there could be multiple different tangent lines. There's no single one that we can pin down. And so we really only have these two little line segments. This has a steeper slope, this has a shallower slope, but there is no point that has the exact same slope as for the tangent line as there is for the secant line here. We can also think of the mean value theorem in terms of rate of change. The mean value theorem means that there is some point in the interval AB where the instantaneous rate of change so for example velocity equals the average rate of change. So this is actually quite useful for real-world examples. Two patrol cars, so this is like highway patrol, with radar are 5 miles apart on a highway. As a truck passes the first car, its speed is recorded as 55 miles per hour. 4 minutes later, it passes the second patrol car, and its speed is recorded as 50 miles per hour. If the speed limit is 55 miles per hour, should the driver get a speeding ticket. So go ahead and think about that one for a second. Okay, so let's look at this. At first glance, when the first patrol car uses the radar, then the speed of the truck is 55 miles per hour. The second time around, it's 50 miles per hour. So it seems at first glance like the truck is good to go. However, let's draw this out and let's look at something. So here's our little road. And here's one little car. Little lights on top. Woo. Here's the other little car. Lights on top. There we go. We know they are 5 miles apart. Now, one of the things that's hidden in the problem here is that it takes the truck 4 minutes to go all this distance. So that means that the average speed of the truck between patrol cars is 5 miles in 4 minutes. Now, we're working in miles per hour earlier, so that means we should convert these minutes, 60 minutes, in 1 hour. So 5 times 60 divided by 4, 75 miles per hour. Now, the mean value theorem and we assume the truck is not able to teleport, so it is continuous. And because it's impossible to change speed instantaneously, the derivative, the velocity, also needs to be continuous, even if it might change quickly at some point. The mean value theorem indicates that at some point, well, really time, between the first car and the second car, the truck's instantaneous speed must have been equal to its average speed over the interval. So the truck should get a ticket because at some time its speed was 75 miles per hour, which is well over the speed limit. And in fact, because this is an average speed, that means that at sometimes it was probably going slower and sometimes it was probably going faster. So she really get a ticket because it's probably going even faster than 75 miles per hour at some point. But this would hold up in court because we know that at some point it was going exactly 75. That's guaranteed by the mean value theorem since all conditions are met. And 75 is way over 55. So let's look at another just sort of more pure mathematical example with this. The value of C that satisfies the mean value theorem, value there are other mean value theorems, so this is the one we know. On the interval (0 to 5) for the function f of x equals x cubed minus 6x is what? So first we have to remember what the mean value theorem is. Mean value theorem means that f prime of c equals, in this case it's going to be f of 5 minus f of 0 over 5 minus 0. So we can find f of 5. That's going to be 5 cubed minus 6 times 5 minus 0 cubed minus 6 times 0. 5 minus 0 is just 5. So this is 125 minus 30 all over 5. That is 95 over 5, or 19. So that means our problem is to find f prime of c such that, find c such that f prime of c equals 19. So we're going to be working with the derivative, so let's start off with our original function. F of x equals x cubed minus 6x. F prime of x equals 3x squared minus 6. And we want f prime of that to equal some number, 19. So 19 equals 3x squared minus 6. Add 6 to both sides, 25 equals 3x squared. Divide both sides by 3. X equals the square root of 25 thirds, or 5 over root 3. This is plus or minus, this is plus or minus. However, notice that we are only want a number between 0 and 5, so that means we have to have a positive number. So that means x equals 5 over the square root of 3.